All right, we are moving on to section 2.3, which is talking about angles. Let's jump straight into it. The first part says most people know what an angle is, but many have difficulty giving a good definition. Think about the figures we have already discussed: a ray, a segment, and a line, and also a point. It defined an angle. An example is given below. So the students had to look at this, and they worked together in their groups, and they were trying to figure out what are the objects that come together to make an angle. Some thought it was lines coming together, but the lines don't, or lines go infinitely far in both directions, and these didn't. So they finally got to the point where they realized it was rays. So they got a definition of two rays with a common endpoint is going to make an angle. The next part says Max is trying to bring the class's attention to the angle that the arrow is pointing toward. He said, take a look at angle T. Knowing the vertex can be a defining part of an angle. Explain what the issue is. How could he change how he described the angle to ensure that people knew which angle he was talking about? Well, the issue here is that there's too many angle T's, meaning there's too many angles that have the same vertex. There is basically the one he's talking about, the one next to it, and then the one that covers both of those angles. So what he needed to do was he needed to name it in a different way. Students came up with the way of putting down PTL or LTP. So that was a way that you could talk about that specific angle. The way I described this was if I only had one, let's say, Mikey in one of my classes, I can just say Mikey and everybody knows what I'm talking about, and that's fine. If I have two Mikeys in the class, I have to give more information. So maybe Mikey and then the last initial or something like that, and then they know who I'm talking about. It's the same thing here. If it's ever possible that you can just say angle and then what the vertex is, then that's good enough. And if not, then you're going to have to go over and pick one point from one side, the vertex, and then a point from the other side. Make sure the middle point is always your vertex. The next part says Max is now trying to bring attention to this angle with the arrow. Is there likely going to be any confusion as to which angle he's talking about when he says angle T? The answer is no. There's only one possible angle here. I guess you could say there's the acute angle and the other angle that's over 180, but whenever we look at an angle, we're talking about 180 degrees or less. So there's only one angle T, so you could say just angle T. The next one is an angle bisector has been added to angle T. How would you describe what the object is that's an angle bisector and what it does? So it appears to be a ray, and that ray appears to be cutting the angle in half. And that's what an angle bisector is. Bisect means cut in half. So you can have segment bisectors, but you can also have angle bisectors. Below that, they have a new notation that they want you to get used to. It says M of angle PTM equals 20 and M angle PTL equals 40. And they had to just try to figure out what possibly could that notation mean. And they saw that that was corresponding to the number of degrees for the angle. So they realized that this must just be the measure of the angle. So that is the notation. They figured that that was the most efficient way to say the measure rather than the actual angle. So that's it. It means the number of degrees or the measure of the angle. Now, if you're wanting to say things are congruent, but you don't know what the actual degrees are, you can see what I just put there. That is just like you have one tick for line segments, and then 2, 2, 3, 3. You have arcs instead for angles. So this is one arc and one arc, meaning they are congruent. And if in that figure you had two other angles that were congruent, but not congruent to these original ones, then it would be 2 arc, then 3 arc, and so on. And this last part, it says, give your understanding of the notation of measure of ABC to approximate the measure of ABC in this figure right here. Justify your reasoning. So students said it looks like it's about 100 degrees, and their justification was, I know what a right angle looks like, which is 90, and this is slightly bigger. So they did find out that they thought this was 100 degrees, and then they used their protractor and set their protractor on there and found out it truly was 100 degrees. So putting all this stuff together into our quick notes, if I have an angle such as the one that is shown there, since there's only one possible angle you could be talking about, you could call that angle B or ABC or CBA. If you use 3 points, the middle point has to be the vertex. Remember, an angle is just two rays with a common endpoint. You have to use your 3 points if there's any ambiguity or if it's ambiguous as to what angle you're possibly talking about. We talked about what acute, right, obtuse, and straight were. Less than 90, equal to 90, greater than 90, and 180. We talked about that an angle bisector is a ray that cuts an angle in half. Adjacent means two angles that share a side and a vertex. They're right next to one another. Complementary are two angles that add to be 90, and supplementary are two angles that add to be 180. So a way that you can remember that is if you draw the letter S and a C, you can make an S into an 8 for 180, and you can make a C into a 9 for 90. And that shows you that complementary is 90 and supplementary is 180. Once the students were done with that, they did practice some. So on the first one, they knew that this was obtuse because it was over 90 degrees, and then they used their protractor. So the issue with protractors are they make it so that you can measure from each side. So every time you measure, that's going to give you two options. For example, this one gave the students the option of 125 or 55. It had to be one of those two. And since it's obtuse, the only possibility is 125. It was basically making it so that you were measuring from one side, not from the other way. The next one tells you what the measure of the angles are, and we had a diagram. So I went over and labeled the diagram with the number of degrees for each part, and I was able to find that if one of the angles was 35 and the two together were 115, then 80 must be left over. So that was 80 degrees. The next one talks about how you have an angle bisector. If you have an angle bisector, it means it cuts the angle in half, which means those two things have to be the same, the 33 and the 4x plus 1. And when you solve, you get 8. And then for our last one, it was practice with the sometimes, always, or never problems. So when they say two acute angles add to be an obtuse angle, that's sometimes, because it could be two smaller acute ones like 30 and 30, and they stay acute. Or you could have 50 and 50, and that is going to be greater than 90, which makes it obtuse. The next one is two adjacent right angles make a line. That's going to be always. If you make a right angle and then you make another right angle next to it, it ends up making a straight line, which is 180 degrees. And lastly, two obtuse angles are supplementary. That's never, because if you have the angles are obtuse greater than 90 and you add them together, it's got to be greater than 180. Therefore, it's not obtuse. All right, let's go ahead and look over the homework. Problem number 1, you're supposed to name the angle where the arrow is, and you could name it BAC or CAB. It does not matter. You cannot call it angle A because there's too many angle A's. The next one says, give an example of an angle that has these qualifications. So adjacent to AGB, if you trace out A to G to B, there are many different possible angles you could say share a vertex and a side. I went over and listed a bunch of them. You probably said BGC or AGF, but there's many, many other ones that you could have. I just listed a bunch of them. Supplementary to BGC. BGC, you're basically trying to find something that is next to it and makes a straight line. That's going to be the easiest way to make it supplementary. Supplementary don't have to be adjacent, but if it's making a straight line, it makes it way easier. So BGF, and also the other one would be CGE. Those would be two examples of angles that would go along with BGC to make 180 degrees. Complementary to AGB, to BGC. BGC, the angle that goes along with that one, where together they make a right angle, would be AGB. An example of an angle bisector must be a ray, and the only one where you see the angles being congruent would be GM. A right angle, there's so many options, but one of them would be AGC. Just make sure that it ends up being a 90-degree angle. An example of an acute angle, there's many options, but I did AGB. That one is less than 90. And then lastly, an example of obtuse angle. There are many, many options. I just picked any one that was over 90, which was FGB. Okay. The next one says AB is an angle bisector of CAD. So I drew out CAD and I made an angle bisector. And I put the congruent marks to tell myself that they were congruent. We know that CAD, the whole angle, is 80 and CAB is 4x. So we know that half of that 80 is 40. So the 4x must equal 40, not 80. So when you put 4x equaling 40 and you solve, you get 10. The next one, we have two angles that are coming together to make the whole. There's actually a name for this. It's called the angle addition postulate. So when we have this, you have a 4x and a 6x plus 10, and they're coming together to make a 40-degree angle. So you can add them together, set it equal to 40. When you solve, you get 3. Okay. The next one says measure using a protractor. You should be within 5 degrees. If you set this on, it would give you an option of 140 or 40 because it depends on which way you're measuring from. And since it's obtuse and the only options are 140 and 40, the only answer is 140. And then lastly, 2 angles are complementary. One is twice the measure of the other. What are each of the angles? Well, you could guess and check, but I did an algebra-based way of saying one of them is x, I don't know what it is. The other one is double that, so I say 2 x's, and altogether we have an x and 2x, which is 3x. 3x equals 90 because it's complementary, and when you solve, you end up getting x being 30, which tells you one of the angles is 30 and the other angle is 60. All right, hopefully this made sense. The most important things are make sure you know the notation for angles, know when you can use 1 point, just the vertex, when you need 3 points, the different types of angles, acute, right, obtuse, and straight, angle bisector, adjacent, complementary, and supplementary. Make sure you understand all these terms and also know how to use a protractor. All right, thanks for watching. Bye.